For this exercise, you'll use the SQL Query tool to run several SQL statements that retrieve data from the customer's collection. To begin, go to the connection tree and right-click the customer's collection node and select Open SQL. This launches the SQL Query tool in its own tab in the main window. As we see, the SQL tab is divided into two sections. The top section provides a command prompt for running SQL statements. By default, the command prompt is pre-populated with a select statement that retrieves all data from the current collection. The bottom section is similar to that of the bottom section of a collection tab, where we have a results, a query code, and explain tabs. But in addition, it also includes the SQL Query tab. This displays the SQL query associated with the current results. Until you run a statement, this tab will be blank. To display all documents in the collection, click the Run button on the toolbar. And at the bottom, we see the collection includes 1,000 documents. Now, go to the Query Code tab. By default, Studio 3T displays the Mongo shell statement used to retrieve all the documents from the customer's collection. This statement calls the find method on the customer's collection. Because no arguments are passed into the method, the statement returns all documents in the collection. At the command prompt in the SQL editor, replace the existing code with the following select statement. The select clause limits the results to the first, last, and interests columns, and the from clause specifies the customer's collection as the target data source. Now click Run. This query should return all 1,000 documents, but only showing the first, last, and interests fields. Switch to Table View if it's not already selected. If the values in the interests field are not displayed, then right-click one of the field's values and click Show Embedded Fields. Let's replace the existing code with the following select statement. The statement is similar to the previous one, except that it now includes a where clause, which limits the results to customers who were born before January 1st, 1990. Press the F5 key, which is the equivalent to clicking the Run button, to run the select statement. This statement should now return only 812 documents rather than the full 1,000. Again, we want to replace the existing code with the following updated select statement. Press F5, and as we see, the statement adds an order by clause, which sorts the documents by the customer's last names alphabetically, and then by their first names. By default, the values are sorted in ascending order. Now let's try replacing the code again with the following select statement. Again, run the statement by pressing F5. And now the statement expands the where clause to limit the results further to those that include the term database in the list of values in the interests array. This new search condition uses the like operator and the % wildcard before and after the specified value. By using the wildcard, an array value can include the search term anywhere within the value for the document to be returned. For example, the statement could return documents with any of the following array values: database, databases, NoSQL databases, or database SQL. Because of the added search condition, the query now returns only 17 documents. And this time we'll replace the existing code with this new select statement. Press F5. And the where clause now includes an additional search condition stating that an array value can include either database or gaming, or both. Notice that the two search conditions are connected with an OR operator, indicating either of the two conditions can evaluate to true for the document to be returned. This query now returns 33 documents. In the Query Code tab, notice that the find statement includes the query, projection, and sort sections. The query section uses regular expressions to limit the results to those documents that contain either database or gaming in the interests array. The regular expressions are the values associated with the two interests array elements. Forward slashes enclose each expression, followed by the I option, which indicates that the search condition is case insensitive. The expression itself begins with the caret anchor and ends with the $sign anchor. These are added by default to help better utilize the indexes. The search term itself, database or gaming, begins and ends with the period asterisk combination, which matches any alphanumeric character that appears 0 or more times. This makes it possible to find the search term regardless of where it appears in the array value. Let's again replace the existing code with the following select statement. The statement is similar to the previous one, except that it adds the date of birth field to the select clause, specifying the field name as an argument to the year function. The function is used by multiple database management systems to extract the year from a date-time value. Press F5. The statement returns an error stating that the year function is not supported. As this demonstrates, SQL Query does not yet support all SQL statement elements. If you encounter this issue, you'll need to modify your statement, run it to verify whether it works, and then update the Mongo shell code manually to get the exact results you want. Leave the SQL tab open for the next exercise.